This video on metal and non-metal part 9 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 8. So till now we have reacted metals with oxygen, with water and with acids. But still we were not able to find the exact reactivity. See, for example, we had doubt between potassium and sodium, we had doubt between gold and silver, we had doubt between copper and lead. So what should we do? Now let's have this 1-to-1 fight, and the winner is the one which is more reactive, right? So let's react with metal salts. For example, in this case, the fact is the more reactive metal will displace the less reactive metal. More reactive metal will displace, the stronger metal will displace the less reactive metals from their compound in solution or molten state. For example, we'll take this. With this, if you see that, as I told earlier, we have used this hydrogen oxygen acid, but we are not able to determine the reactivity series. So we are using displacement reaction that will give you better evidence of the reactivity. That is, the rule is very simple. If the metal A displaces the metal B from its solution, that means it is more reactive, as A is more reactive than B. Correct? Pretty simple. So if I have metal A plus solution of metal B, so if this will give solution of metal A and metal B is out, right? If this guy kicks metal out from the solution, if metal A kicks metal B from its solution, that means A is more reactive than B. With this rule we'll find. So scientists has done a lot of experiments on this and they have found that this is the reactivity series. For example, till now we were able to find that we were having confusion in this. This was clear to us. This was a confusion. This was a confusion, right? So, for example, lead and copper. So we have to find which one is more stronger. So you take this lead and you take copper solution, right? You react. You will find that you get PbCl2 plus copper. That means if you see that lead has displaced copper out. So we see that copper has came out. Thus I can say that lead is more stronger than copper. So if you see hydrogen we have placed here, because if you take let's suppose iron, or you take potassium, anything you can take. So you can take iron and you take H2SO4, right? You get FeSO4 plus H2. That means iron is able to displace hydrogen also from this. So iron is above hydrogen. In fact, lead will also be able to displace hydrogen from this H2SO4. So you take Pb and you take H2SO4, you get PbSO4 plus H2. But copper will not be able to displace this one. So this hydrogen is above copper. So that's why if you see gold and silver also, they have done like this. So end of the day, this displacement reaction is the best way actually to find the reactivity of the element. Correct? For example, let's suppose we want to find the reactivity of iron and copper. Okay. So what we'll do? We have this iron. We'll take this copper solution, copper sulfate. You'll react it. You get copper plus FeSO. That means what? Iron has kicked out copper from the solution. So iron is more reactive than copper. Same thing you can take for, let's suppose, manganese and copper you want to take. You can do the same thing. You have this manganese, you take copper solution and you'll find that you get MgSO4 plus copper. So manganese took out this copper and the copper is out now. So with this I can say that manganese is more reactive than copper. Why it is more reactive and all? We will study atoms. We'll study the structure of atoms, the electrons and all, and the valence electron and stability thing. That we will do later, maybe in the next 2 chapters. But now just understand manganese is more reactive than copper. Correct? So with these kind of things you can easily find. Example, zinc and copper. If you want to find zinc is stronger than copper or not, you take zinc and you take copper sulfate solution. Again, then what you will get is zinc sulfate and you get copper. So here also if you see, zinc has kicked out copper and copper is out. So that means zinc is more stronger than. So let's suppose you take sodium and hydrogen. So hydrogen is not a metal, but we have put this in this. because sometimes hydrogen behaves like a metal also. So we have the sodium, and let's take this hydrochloric acid. You will see that this becomes NaCl and my hydrogen is out. So sodium has kicked out hydrogen from this and become NaCl. So now is the question time. The first question is, why sodium immersed in kerosene? Because sodium is very reactive. So sodium, it will react with moisture in the water, air to becomes NaOH. So that's why sodium is kept in the kerosene oil, so that it should not get in contact with water, right? Not contact with moisture also. You have to write the equation for iron with steam. So we have this iron, we have this steam, there is water, very, very hot. This gives Fe3O4 plus H2. We can balance this 3 iron metals, make it 3 here, 3 combine. Hydrogen is 2, oxygen is 4 here, so make it 4 here. And since it is 4, it's 8 hydrogen now, make it 4 here. This is my reaction of iron with steam. Calcium and potassium with water. So let's do this. Calcium is Ca with water is H2O, gives CaOH2 plus hydrogen plus heat. Correct. So let's balance this. Calcium is 1 correct only. Oxygen is 2 here. You get 2 here. So hydrogen becomes 4. Hydrogen is 4. It's all balanced. Similarly, potassium. Potassium is K plus water gives potassium hydroxide KOH plus H2 plus heat. Let's balance this. Potassium is 1 balanced. Oxygen is 1 balanced. Hydrogen is 3 here. Hydrogen is only 1. So let's multiply with 2. You get 4. So you will multiply with 2. 2 plus 2, 4. It becomes 2 potassium. It's 2. This is balanced now. Correct. So this is my balance. The question says sample of 4 elements were taken and added to the following solution one by one. The following results were obtained, right? So we have to find what do you observe if B is added to copper sulfate solution. This is the first question, and we have to arrange the activity, these things in the decreasing order of reactivity. So let's see this properly. Please pay attention here. The first one says that A, when react with iron sulfate, there is no reaction. That means I'll write here A plus iron sulfate is FeSO4. There is no reaction. There is no reaction. That means A is lesser than iron. So let me write iron somewhere here. Somewhere we'll write iron. And my A is below iron. Correct? This part is done. Second, it says when A is react with copper sulfate, A react with copper sulfate, there is a displacement. That means A is weaker than copper. Correct? Sorry, A is stronger than copper. That's why displacement is happening. A is displacing copper. That means A is stronger than copper. So copper will be somewhere here. Hope you understand this. Since A was not able to displace iron, A is weaker than iron. So this is my reactivity series, right? This is more reactive to less reactive. This is more reactive to less. So since A was not able to displace iron, that is iron is more reactive than A. But A was able to displace copper, A is more reactive than copper. This is also done. The third is B is when react with iron sulfate, no displacement. That is B plus FeSO4, there is no displacement. That is B is weaker. Sorry, there is a displacement. Sorry, there is a displacement. There is a displacement there. That means B is able to displace iron from here. That means B is stronger than iron. So we'll put B somewhere above iron. Correct? B is stronger than iron. That is B is able to displace iron sulfate. This is done. When B reacts with zinc sulfate, there is no reaction. So I will write here B with zinc sulfate, no reaction. That is B is weaker than zinc sulfate, right? So zinc sulfate is stronger than B, that means, correct? So we'll put zinc is stronger than B somewhere here. Hope you understand. When B reacts with zinc sulfate, nothing happens. As B is weaker than zinc, zinc is stronger than B. That is done. So this is also done. C, when reacts with iron, there is no reaction. So C plus FeSO4, there is no reaction. That is, C is what? Weaker than iron. So weaker than iron, I can place C anywhere. From here I can put C anywhere. C can be somewhere here, somewhere down this line, right? We don't know where it is, but somewhere down C will be, right? Somewhere down the iron, correct? We don't know the actual position where C will be, but somewhere here it will be C. So C is there. C with copper sulfate, no reaction. C with copper sulfate, no reaction. So that means C should be somewhere below copper sulfate, right? So C should be somewhere here. We don't know, correct? Because C is not even reacting with copper. So C is somewhere below copper. Zinc sulfate, C with zinc sulfate, no reaction. That is, C is below zinc. C is already below zinc, so no need to worry. But we don't know the correct position of C, right? Maybe C is just below C, we don't know, or somewhere here, but C is something below C. So we don't know. C, when reacted with silver nitrate, there is a displacement. That means C is stronger than silver. That means after C you have silver. That means, let's suppose silver is here, then C should be somewhere here, correct? I'll put C here, correct? No issue. That is also done. D, when D reacts with iron sulfate, no reaction. That is, D is weaker than iron. So D can be some anywhere here. I'll just put here for timing. I'll put here for timing D. D reacts with copper sulfate, no reaction. No reaction. So D will be below copper, right? Anywhere below copper. D reacts with zinc sulfate, no reaction. So D is anywhere below zinc. D reacts with silver nitrate, no reaction. So D reacts with silver nitrate, no reaction. That is, D is even bigger than silver. That is, D is somewhere below silver actually. That's the actual position of D. So D is actually here actually, so, right? So this is my order which I have got. Zinc is most reactive and D is less reactive, right? So now the question is, what will you observe is B is added to copper sulfate solution. So B is added to copper sulfate solution. If you see, B is more reactive than copper. You see, B is more reactive than copper. That means if B is added to copper sulfate reaction solution, there will be a displacement reaction. Why? Because B is more stronger than first part is done. Second part, arrange the order these elements in the decreasing order of reactivity. The most reactive is what? B, and then I have A, then I have C, and then I have D. This is the order. Yes. Hope you understand how I've done. I reacted all these elements. A with iron sulfate, no reaction, that is A is weaker than iron. I reacted A with copper, displacement, that is A is stronger than copper. Similarly, B with iron, displacement is B is stronger than iron. B with zinc, no displacement, that is B is weaker than zinc, that is zinc is stronger. And that's how we form this reactivity series. Once I have the reactivity series, I can answer any of the questions. Let's take one more example. Which gas is produced when dilute hydrochloric acid is added to the reactive metal? So I know that metal plus HCl dilute gives me hydrogen gas. That part is solved. Write the chemical reaction where iron react with H2SO4. So I have iron, it reacts with H2SO4, it will give you FeSO4 plus hydrogen gas. And this is my reaction. Correct. What will you observe when zinc is added to the solution of iron sulfate? That is, I have zinc, I have iron sulfate. I know that zinc is more reactive than iron sulfate. That means it will displace iron from this. It will become zinc sulfate plus iron, right? Because zinc is more reactive than iron, we know from the reactivity series. Thank you.